So in this video, I'm going to review how to find the surface area of certain 3D shapes. And my goal for the video is to help you learn how to read the shapes so that you know which dimensions you're actually going to be plugging into the formula. Now, the first thing I want to do is point out that I've got the steps shown, 1, 2, 3, and 4. First thing you're going to do is identify the name of the 3D shape. Then you're going to provide the surface area formula from your formula sheet. You're going to show the work with the dimensions plugged in, and you're going to answer with the correct units squared. Okay? So the first example that's done for you on your paper is of a rectangular prism, and I think most of you are comfortable with the surface area of a rectangular prism, and there is an example there for you. Again, I've got work steps 1, 2, 3, and 4. Now, let's take a look after you've gotten situated. We're going to take a look at the first question here. We're going to find the surface area of what is a triangular prism. Now, this one is oriented in a way where we can see the fact that we have a triangular bottom. And let me just get a red line real quick. And so you can see right here, that would be the triangular base. Now, off to the side, I have that triangle. It's also here up top because we're going to need to use the Pythagorean theorem to find this side of the right triangle. Now, let me back up and explain why you're going to need that. So first, here, we're dealing with a triangular prism. So go ahead and jot that down if you haven't already. And this is the formula from the formula sheet. The H stands for the height of the prism. The H stands for the height of the prism. And that's going to be this 9 right here. Now the P stands for perimeter of the base. So the perimeter of that red triangle is going to be the 6 plus the 8 plus this hypotenuse. So if you use the Pythagorean theorem, we can get that it's a 10, and therefore when we add up the three sides, we're going to get a 24. That's this 24 in the formula. So again, the H stands for the height of the prism. The P stands for perimeter of the triangular base. Then you have, you're going to add, because you're covering it up, 2 times the area of the base. So this capital B stands for area of this red triangle. Now the red triangle is an 8 by 6, so that's why you see for base and height I have an 8 by 6, and then because it's a triangle I cut it in half. So that would be 24 is the area for one triangular base, and then we're going to double it because there's a bottom and a top. So that'd be 48. So then you just add the 216 plus the 48, and you get 264 square meters. Now for number 2, we have a cone, and the surface area formula is pi r squared plus pi rl. And now I want to explain this L. The L is for the lateral slant height, which is going to be the 13, okay? Eventually, we're going to be filling up the cone, and we're going to need to solve for h, but you actually don't need to solve for h. You can ignore that right here. We would need that measurement if we were filling this cone up, but we're not. We're covering it up, okay? So that being said, pi is 3.14, the radius is 10, we're going to square it. Then over here you've got pi, the radius once again is 10, and the L would be that slant height. The L is again the slant height. And so when you multiply 3.14 times 100, we get 314. When you multiply the 3.14 times 10 times 13, we get 408.2. So the total surface area there would be 722.2 square units. Now folks, if you're not using a calculator and punching in the math along the way with me, please pick up a calculator and start to do that. I think it's very, very important that you practice the math along the way. Now number 3 is going to be the trickiest problem by far. I'd like you to look at your formula sheet, and you're going to notice that it's actually a square pyramid on your formula sheet. The formula on the formula sheet will only work for a square pyramid. What we have here is a rectangular pyramid. So we can't say that there's going to be 4 of the same face and our formula won't work. Now this you're definitely going to need to pay attention to. I'm going to get a red line again, and I'm going to show you this triangle inside the pyramid. From here to here to here is this right triangle. Now the reason I need the Pythagorean theorem is because, and now I'm going to highlight it just so it stands out, we need to find this height of the triangular face. Because what we're eventually going to do here to cover up this pyramid is just old-fashioned area of the bottom plus 2 of the front areas. So like right here, that front triangle is going to be this 1/2 base times height. And I'm going to double it because that triangle is also the exact same one on the back of the pyramid. So to find the height of that triangle, I need the measurement of this part of that red right triangle that I drew in there. So the red right triangle has a height of 7.3, and the base of this triangle is half of the 8.4. That's where I got this 4.2. So when you use the Pythagorean theorem, 7.3 squared plus 4.2 squared, you get 70.93. And then when you hit the square root, you get an 8.4. So in the work down here, I'm going to focus on the 2 triangles that I'm finding the area of. And let me just erase that so it's not confusing. The area of this triangle would be half the 12.5 times the 8.4 height that we just found, which is right here. And then in the calculator, if you just want to do the 12.5 times the 8.4, you can kind of ignore the half times the 2 because that cancels out. And that's going to be the 105. That's where I get this blue 105. Now I'm going to erase, and we're going to focus on a different right triangle inside the pyramid, because this time what we're going to focus on is going to be over here. We're now going to find the area of this green face off to the side, and then we're going to double it because there's 2 of those green triangles. All right, so that's this part right here. So for that one, the right triangle on the interior of the pyramid that we want to use is going to have that same height of 7.3. Right there, it's going to have a base of half of the 12.5, so the 6.25. And then right there, when we find the hypotenuse of it, that's going to end up being the height of that front face green triangle. So over here, I got the 6.25 because it was half of that 12.5. It's just half right there. The height's still the 7.3. And again, when you use the Pythagorean theorem, you're going to get a 92.3525. And then when you hit the square root button, you're going to get a 9.6. So for the side green triangles, I've got the 8.4, that's the base, times the height, which is 9.6. And then again, you can kind of ignore the half times 2 because that would cancel out. And so the 2 side triangles are the 80.64. Now the bottom is a rectangle that's just a length times width, and that's this part. And when you multiply 12.5 times 8.4, you get 105. So for this shape right here, there is no formula on the formula sheet for it. The pyramid on the formula sheet is only for a square pyramid where all 4 triangles are going to be the same type of triangle. Here you have 2 pairs of triangles on this rectangular pyramid. So the best way to cover this shape up is to think of it kind of like a 2D composite figure, where you're going to find the area of each face and just add them all together. Okay? So now let's flip over. For number 4, this one's going to be pretty straightforward. It's a cylinder. A lot of you have worked with a cylinder before. The formula on the formula sheet to cover it up is 2 pi r squared. All right, that's the top and the bottom. And then we've already talked about how the 2 pi r is the length, and then the height is the width, and that covers up the curvy lateral face. So when you plug in the numbers, you're going to do 4 times 4 times 3.14 times 2. You get 100.48. When you crunch these numbers, you get 175.84. And when we add them together, we get 276.32. Now, number 5 is the other really tricky problem that's going to kind of take some focus. This is a triangular prism, but the way that it's oriented, it looks like it has a rectangular bottom. So I want you to imagine this thing kind of sitting more upright, kind of like a block of cheese, where you have something kind of like this from the side. And that'll kind of help you see that if you stand it so that the triangle is the bottom part with a top, that'll help you realize that the height of this prism is actually this 5. The height would be the 5. Okay? So the formula on the formula sheet is HP plus 2B, and we've already seen it right here, HP plus 2B. But this shape was a little easier to work with because the way it was oriented, it looks like the triangle's on the bottom, so it helps you realize you're using the perimeter for the triangular base and that the height is right there as the 9. The way this one's turned, it's tougher to catch that the height's actually a 5. So that's where I got this 5 right here. Now the perimeter of the base is going to be this 5 plus this 13 plus this 12, and that's 30. So that's where I got this 30. And then we just multiply and we get 150. Now we're going to find the area of that triangle, and it's half base times height. The base is this 5, and the height is actually this 12. So 5 times 12 is 60. Cut it in half, you're at 30. Then double it because there's a top and a bottom, so you're back to 60. So when you cover this shape up, we get 210. And for the last one, for a cone, to cover it up, you've got pi r squared that's going to cover up the bottom, and then you have plus a pi r L. So the L, once again, that's going to be the height of the lateral face, so that's the slant height. And we have a right triangle, so we're going to need the Pythagorean theorem. When you use the Pythagorean theorem and plug in the numbers, we actually get a 13.3 here for the hypotenuse, and that's going to be what we plug in right here for L. Now you know you've got 3.14 for pi, and the radius in the picture is a 5.7. And so when you plug in all of the numbers, you're going to get a 340.062. Now the reason I wanted you guys to punch the numbers in the calculator along the way with me is because you'll see things that you get in the calculator and where I'm choosing to round in my work. So like right here, if you punch that in the calculator, you'll see that you get that long decimal. And if you punch this in the calculator, you'll get that long decimal. Some of you might just choose to round to the nearest hundredth along the way, which is fine. And you're going to add up and get that, which is essentially the same thing I get, and we can just round to 340.1 square centimeters. So that takes care of how you're going to cover up these 3D shapes. And I think that realistically the toughest formula here is going to be the triangular prism. It's the HP plus 2B. And then the other thing that's going to be tough for you guys is to catch that, like, if it's a rectangular pyramid, the best you can do is to just add up all the faces. If it's a square pyramid, that L is going to be the same slant height on all 4 faces in that formula you see. So that's why the formula will work only for a square pyramid. At this time, you are now going to be working on the next page in the packet. That's where you're going to show your work to go along with 9 problems that you're going to see on Google Classroom. Thank you.